Within 59 days, Anthropic, OpenAI, AWS, and Microsoft all announced a version of the same move. They put engineers closer to customer operations. OpenAI, AWS, and Microsoft alone described more than $7.5 billion across different kinds of commitments. If model capability were the whole problem, why are model companies spending billions on people? The numbers are not perfectly comparable. OpenAI described the investment in a new company. AWS and Microsoft described organizational commitments. So I would treat $7.5 billion as a scale signal, not a clean spending comparison. But the shared priority is hard to miss. These companies are building deployment capacity. Models can already write code, analyze documents, and call tools. What they cannot do by themselves is organize a company's data, permissions, approvals, recovery paths, and the responsibility into a reliable production system. That gap is where forward-deployed engineering becomes important. Imagine a manufacturer loses a critical supplier. Supplier data lives in one system. Production capacity lives in another. Customer orders live somewhere else. Some approval rules exist only in the heads of experienced employees. The useful question is not, can we add a chatbot? It is, which orders are now at risk? What options do planners have? And who is allowed to approve a change? A forward-deployed engineer works through that decision with the operators. The team connects the data, defines the objects that matter, builds the action, and includes permissions, approvals, exceptions, and the recovery from the beginning. That is deployment work. Palantir has a useful phrase for this. It calls forward-deployed engineering the human equivalent of backpropagation. The phrase sounds academic. The job is practical. A planner finds an exception. A data source arrives late. An approval path blocks the wrong person. The engineer fixes the local system, then asks a more valuable question. Will this failure happen again somewhere else? If the answer is yes, the lesson should return to the product. The next deployment should begin with a better connector, permission model, evaluation, or workflow primitive. That is how field work compounds instead of becoming Endaly's custom service. I see a smaller version of this in my own publishing workflow. If someone says AI produced a truly good article in 5 minutes, they are hiding most of the work. My first workflow connected research, outlining, writing, translation, images, audio, video, and publishing. It was fast. It was also capable of moving weak evidence, awkward language, repetitive visuals, and the broken links all the way to the end. The second version required more participation. Rereading, rejecting, challenging claims, comparing visual directions, and testing the final package. Quality improved when those judgments became evidence gates, editorial rules, and validators. This does not prove FDE works at enterprise scale. It does show the same working pattern. Stay close to real work, find what general capability misses, and write the correction back into the system. It is too simple to call FDE consulting with a new title. Good consultants and systems integrators already understand the workflows, manage change, navigate regulation, and coordinate complex transformations. Forward-deployed engineers do not own those skills. The useful distinction is the connection between field work and the product. A strong FDE team stays close to production and close to core engineering. If an engagement ends with custom code, a handoff, and the deeper vendor dependence, the new title proves nothing. If the customer can run the system and the field learning improves the platform, the model is doing something more valuable. That closeness creates a risk. A critical workflow can slowly bind itself to one vendor's connectors, evaluations, permission model, agent runtime, and assumptions about how work should happen. The deployment may look successful while the customer's ability to understand or change it gets weaker. The customer needs to keep the durable parts: data contracts, evaluation sets, permission rules, audit history, runbooks, failure modes, and the interface between the workflow and the model. A good engagement leaves the customer more capable, not simply more dependent on a capable vendor. Actor is part of my deployment framework. It gives me 5 questions before I call an AI deployment successful. Action: name the real decision, handoff, or task that will change. Context: define what the system must know and what it is allowed to access. Trust: decide whether the AI is drafting, recommending, deciding, or acting. Set the approval and the recovery path before it fails. Outcome: choose the evidence that would prove the work improved. Recursive: show how this run will improve the workflow and the next run. That last word matters. A loop in a diagram is not self-improvement. Someone still has to notice failures, judge which ones matter, and turn repeated lessons into better evaluations, rules, runbooks, and tools. The goal is not permanent manual work. The goal is to make good judgment compound. Token usage measures model consumption. It does not tell you whether a decision improved, a workflow became faster, or an organization learned anything. That is why the biggest AI platforms are building deployment organizations. They are trying to close the distance between intelligence and operations. The title FDE may change. The operating rule will not. Judge AI by the workflow it changes and the capability the customer keeps. The real question is whether expensive tokens become an operating system the company actually owns.